All right, one more here. Problem 6, finding finding the angle between two unit vectors. They don't specify here what dimension we are in. Okay, so I guess let's just pretend that we're in two dimensions. And so what we'll say is we know that vector u can have x1 and y1, and vector v can have x2 and y2, and we know that they are unit vectors, and so that means that their components, they have a magnitude of 1. And so we know that then 2u minus 3v is going to equal 2x1 minus 3x2 and 2y1 minus 3y2. And the other vector, 5u plus 2v, is 5x1 plus 2x2, 5y1 plus 2y2. And when we know that things are perpendicular, that means when we take their dot product, we get 0. So dotting that all out, oh dear. Okay. So what do we have? We have 10x1 squared plus 4x1 x2 minus 15x1 x2 minus 6x2 squared. So that's just taking the x component times the x component right there. I'm going to write the y components underneath it. So we have really the same exact thing with the y components, right? So we have 10y1 squared plus 4y1 y2 minus 15y1 y2 minus 6y1 squared, and that all has to equal 0. Okay, let's see. We know as well that, like I said, these are unit vectors, so we know that x1 squared plus y1 squared equals 1. We also know that x2 squared plus y2 squared equals 1. Let's see if that helps us out here. So, we know that then this first term here is equal to 10. This second term here, these are 2's. This is equal to negative 6. And the middle term is equal to negative 11, x1, x2, negative 11, y1, y2, and that equals 0. So what we can say is that x1, x2 plus y1, y2 is equal to, okay, so 10, come on, move out of the way. 10 minus 6 makes 4, so move the 4 over and then divide by 11. That's going to equal 4 out of 11. And luckily, that is also the dot product. And so that would be then equal to, the dot product is equal to magnitude of A times magnitude of B over times cosine theta. So that equals cosine theta. Now the question is, am I supposed to know what cosine of theta gives me 4 over 11? Let's double check. Let's see if there is some more mistakes in here. That would be fun. Great. Yeah, theta is 69. Why did they have a little no calculators thing right next to that? I don't know. Great. Okay, so on the test, you can leave your answer like this, okay? Or if you wanted to use the inverse cosine, you could do the inverse cosine of 4/11. So, inverse cosine of 4/11, and that's approximately equal to 69 degrees. There are some egregious errors happening in the review section of the vectors textbook. So apologize about that. Try to stick with me on these videos and with the examples in class.